Okay, in this video, we are going to look at adding, subtracting, multiplying, and dividing fractions. And now remember that when you add or subtract fractions, you need to get a common denominator. So in problem 12 here, this is continuing from the last video, we have common denominators. Both of these fractions have a denominator of 9. So what I need to do is just add the numerators together. Keep the denominator the same, so 2/9 and 1/9 is 3/9. And 3/9 can be simplified to 1/3. Okay, problem 13, my two fractions have different denominators. So I need to get a common denominator before I can add these fractions. So I want to take 2/3 and multiply it by some number on top and bottom of the fraction in order to get an equivalent fraction. I need to do that for both fractions. So what I need to do to figure out the common denominator is to find the least common denominator of 3 and 5. And if you need to, you can go over on scratch paper and list out multiples of 3, 3, 6, 9, 12, 15, 18, and so on, and multiples of 5, 5, 10, 15, until you get a common multiple. Well, that common multiple is your common denominator. So I need to make my fractions equivalent to something with a denominator of 15. So for this first fraction of 2/3, what do I need to multiply by this 3 in order to get this 15? Well, I need to multiply by 5. So I have to multiply numerator and denominator by 5, so I get 10/15. And for the bottom fraction, what do I need to multiply by 5 to get 15? Well, I need to multiply by 3. Because 5 times 3 is 15, you need to multiply numerator and denominator by 3. So now when I add these two fractions, I get 22/15. And that's a perfectly fine answer. We do not need to change it to a mixed number. We can just leave it improper. Okay, for problem 14, I would like for you to try this problem on your own. So pause the video and see what answer that you get. Okay, in that problem we can see that our common denominator is 12, so when we add those two fractions together we get 19/12. One thing I want to point out here is that you don't necessarily just multiply the numerators together. In this case, if you multiply the numerators together, you get 24, and that's not your least common denominator. It's a common denominator, but it's not your least common denominator. So if you chose 24 to be your common denominator, there's nothing wrong with that. You would just have a bigger fraction here at the end that you would have to simplify. Okay, in the next problem, basically the same type of thing, except for now I'm subtracting instead of adding. I still need to get a common denominator. So I need to multiply both fractions by something on top and bottom in order to get an equivalent fraction. So my common denominator here is going to be 10. Well, actually, this top fraction already has a denominator of 10, so I don't really need to multiply that by anything. So I'm just going to rewrite it over here on the right just so they will line up. Now my second fraction, the one on the bottom, the 1/5, does need to be multiplied by 2 on the top part of the fraction and the bottom part of the fraction, so I get 2/10 here. So when I subtract, I get 7/10. And a common mistake here is not that students don't know how to add and subtract fractions, they just sort of forget which one they're doing, whether they're adding or subtracting. We're subtracting here. Okay, for the next two problems, we are still subtracting fractions, so I want you to try these two on your own. So pause the video and see if you can do these. And there are your answers for problem 16 and 17. Okay, this next part, we are multiplying fractions. And remember, to multiply fractions, you do not need to get a common denominator, and you should cross cancel if possible. Now, problem 18, there's no cross canceling that I can do, which is basically just simplifying your fractions before you multiply. So what I'm going to do here is just multiply straight across. Multiply by numerators. 2 times 4 is 8, and then multiply by denominators. 3 times 5 is 15. Right? And there's nothing you can do to simplify that fraction. Now in problem 19, I can cross cancel. What that means is that there's a number in the numerator and the denominator that has a common factor. The 2 and the 4 have a factor of 2 in common. So what I want to do is to rewrite this. Now I'm going to do this slightly different than how you learned this in elementary school, because the way I'm going to do this is going to prepare you for what we're going to be doing with algebraic fractions in intermediate algebra. The 1/2 I'm just going to leave as 1/2. But in the second fraction, I'm going to write 4 as 2 times 2. And the reason why I'm doing that is because I want to cancel this 2 on the bottom with one of the 2's on top. So now I can multiply straight across. 1 times 2 is 2. And on the bottom, you could think of this as a 1 if you wanted to. 1 times 7 is 7. So your answer is 2 7s. Now, if you would have multiplied the fraction straight across, you would have had 4 over 14, which would simplify to 2 7s. Okay, problem 20. I noticed that I have a 4 and a 6 that both have a common factor of 2. So I'm going to write 4 as 2 times 2. And I'm going to write 6 as 2 times 3. And from there, I see that I can cancel this 2 with this 2. Now, the reason why I didn't write the 9 as 3 times 3, because the 9 doesn't have anything that it can cancel with. So now I can just multiply straight across. 2 times 5 is 10, and 9 times 3 is 27. Problem 21. There's a lot of things here that I can cancel out. And if you try to do this in your head, you can see that the numbers are getting really big, and where it's hard to do in your head. 35 times 9 is hard to do. But what you should notice with this 35 and the 14 is both of those have a factor of 7, and the 9 and 12 both have a factor of 3. So I can write 35 as 7 times 5. I can write 12 as 3 times 4. 9 I write as 3 times 3. And 14 I'm going to write as 7 times 2. So from here, I can cancel the 7s. I can cancel a pair of 3s. And then what's remaining doesn't cancel, so I can just multiply straight across and get 15 over 8. Okay, with what we've done so far, multiplying two fractions together, adding and subtracting fractions, is something that we're not really going to see a lot of in this course after this first chapter. But this next set of problems we are going to be seeing time and time again throughout this course. And that's when we're multiplying a fraction times a whole number. And so there's the shortcut that you learned in elementary school, and we're going to go back to. Basically, on problem 21, you could think of this 3 as 3 over 1. And then these 3's will cancel. So you're left with 2 over 1, which is just 2. Now, the easier way to do this, the shortcut, is you take the denominator and you divide it into this whole number. 4 goes into 8 2 times. And then you say 2 times 3 is 6. So let me do that again. 4 goes into 8 2 times. 2 times 3 is 6. 5 goes into 24 times. 4 times 2 is 8. And it doesn't matter which side your fraction's on. On problem 25, you can see my fractions on the right-hand side. 3 goes into 12 4 times. 4 times 2 is 8. So here I want you to pause the video and see if you can do problem 26 and problem 27 on your own. And there are your answers for those next two problems. Okay, so now we're going to move on to dividing fractions. And when you're dividing fractions, you do not need to get a common denominator. You need to take the reciprocal of the second fraction and then multiply. So that just means that we are going to take the second fraction and turn it upside down. We're going to change our division into multiplication. So now we have a problem like we had previously, where we're just multiplying two fractions. So I can cross cancel. 5 goes into 5 one time, it goes into 10 two times, and I can multiply these numbers straight across. 2 times 2 is 4, 1 times 3 is 3. Problem 29. First fraction is going to stay the same. The division changes to multiplication. And we're going to flip that second fraction upside down and have 15/8. So from here, I can look at the numerators and denominators and see if there's anything that's going to cancel. And I can see that the 5 and the 15 have a common factor, 8 and 12 have a common factor. So I'm going to rewrite these numbers so I can cancel stuff out. And so from here you can see I can cancel the 4's, I can cancel the 5's, and then I multiply my numerator straight across. I get 9, multiply my denominator straight across, I get 2. Okay, problem number 30, I have a fraction and I have a division sign, but I only have one fraction here. So what I need to do is to take 6 and make it into a fraction by writing it as 6 over 1. Now I'm going to follow the same process that I've been doing. Take this second fraction and flip it upside down. And from here, I can take this 6 and write it as 2 times 3. And then I can see that the 2's are going to cancel. So my answer ends up being 1/9. On problem 31, when I take the fraction of 1/3 and I flip it upside down, it becomes 3 over 1. Well, 3 over 1 is just 3, so 2 times 3 is 6. And one more thing I forgot to say about the multiplying of fractions let's go back up here and look at problem 28 and 29. You see how in problem 28 I just cross-canceled the 2 and the 10? And over here in problem 29, I rewrote the 12 as 4 times 3 and so on. It doesn't matter to me which one of these ways you do the problem. Either way is acceptable.